Okay, so how is everyone today? Good, I hope. Any questions before we get to business? Any questions? Okay, so last time we were talking about lines. We still have plenty of say about lines, so we'll continue that. Retread just a little bit of ground. Suppose that we are given 2 points. Specifically 2 different points. X1, Y1, X1, Y1, and X2, Y2. Given 2 different points. We can calculate delta x and delta y. So delta x is x2 minus x1, and delta y is y2 minus y1. Concerning the line between these 2 points, so for the line between these points, there's 2 possibilities. The first case is the vertical case. Now, algebraically, how can you determine that you're in the vertical case? When the x values are the same. When x1 is x2, that also means that delta x is 0. That's how you'll know when you're there. In such a case, visually speaking, well, you know what a vertical line looks like. It could be the case that, say, this is x1, y1, and maybe this is x2, y2. Well, those lines are vertically aligned. Sorry, those points are vertically aligned. So that's what that line would look like. What's its equation? Either one, right? Because they're both the same thing. So that could be like, like 3, 2 and 3, negative 1. Then the equation of the line would be x equal 3. Okay, so that's the vertical case. The non-vertical case that's when the x values are not the same, which is to say delta x is not 0. So visually, we've got 2 points. Well, I'll draw the line first, I guess. It doesn't matter. So x1, y1, and another point, x2, y2. And in this drawing, the points are not vertically aligned, because otherwise we'd be in the vertical case. In this picture, delta x is this measurement, delta y is that measurement, and the slope is what? rise over run. So delta y divided by delta x. All right. Now suppose on this line we select any other point whatsoever. So any xy. That is to say, you can imagine that this blue point, this last point that we drew, you could slide it to be anywhere along the line. It could be anywhere. Then it must be the case that if we consider x1, y1, and the blue point, if we consider those two, then y minus y1, the rise, divided by x minus x1, the run, should be equal to what? Should be equal to m for any xy. Then we can multiply both sides of this equation by the denominator of the left-hand side. So take that, imagine that I'm covering up a 5, multiply both sides of the equation by 5. So y minus y1 is m multiplied by x minus x1. Okay, so this is the equation of a line through point x1, y1 with slope m. And this is now something that you're expected to memorize. So this equation is rather uncreatively, or perfectly, depending on your point of view, named the point-slope equation, because it's exactly the data that you have, a point and a slope. Any question about it? Okay. So let's use it. So find the equation of the line. Through the points. So in the first case, how about the points 2 and 3, 2, 3, and how about the point 8 and Gesundheit 1. So that'll be the first one that we do, and then the second one that we'll do is the point pi 13 and pi 14. Okay, so we'll come back to 2 in its time. For now, what do we need to do? Find the slope. So let's make sure that it's clear why we should do that. So we have a formula called the point-slope formula. It's called point-slope because that's the data that you need. And we have in this exercise, we have a point and a point. And we do not have a formula called the point-point formula. So does everyone sort of see, oh, okay, well, if somehow we could determine a slope, then we'd be in business. Okay, so let's find the slope. Well, delta x is 8 minus 2, which is 6, and delta y is 1 minus 3, which is negative 2. Any question about finding delta x and delta y? As a result, which case are we in? The vertical case or the non-vertical case? Non-vertical. It's important to be able to, well, in the first place, know that there's two different cases, and in the second place, be able to identify which one that you're in. Okay, so then the slope is -2 divided by 6, which I'll simplify to -1/3. Any question about finding the slope? Okay. So now we have a point and a point and a slope. All right, a point and a point and a slope, but we don't have a formula called the point-point-slope formula. So what are we supposed to do? Okay, which one? Whichever one you like. Okay, so then it's up to you which point you like. And because it's up to you, you should choose whichever you think will be in your best interest. Usually that means whichever numbers are simplest. So if one of them had a whole bunch of fractions and the other one was all integers, choose the one with integers, right? That kind of thing. So now we'll use the equation. Well, like I just mentioned, we need to select one of the points. I'll select the point 2, 3 for no particularly good reason. And then use the equation y minus y1 is m multiplied by x minus x1. And now it's just a matter of plugging stuff in. So y minus 3 is -1/3 times x minus 2. And the instructions are going to say something like solve for y, so we've got to do some stuff. So y minus 3, and let's distribute the right-hand side. So if we distribute the -1/3, what do we get? -1/3 x, and then plus 2/3, plus because the negatives cancel. Okay, then we'll move the 3 to the other side. Y is -1/3 x plus 2/3 plus 3. And then now we need to simplify 2/3 plus 3. So this is 2/3. How many thirds is 3? 9 of them. So altogether there'd be 11/3. But I know that some of you are a little bit anxious about fractions, so I'm going to go ahead and write that intermediate step there. 9/3, 2/3 plus 9/3 is 11/3. Okay. So so far in the semester, I've more or less kept us in a walled garden without fractions. But this can only go for so long, right? So on Wednesday, we're going to talk about fractions and just review some things that everyone already knows about fractions, and then from now on, there will be fractions in the exercises. Any question about this one? Okay, so then the second part of the exercise, what do we do? We got to figure out what we have here. So in either case, it's good to start out by finding delta x and delta y. So delta x in part 2 is pi minus pi, which is 0, and delta y is 14 minus 13, which is 1. So what does that tell us? It's the vertical case. Which means that the amount of work and the kind of work in this situation is quite different than what's immediately above. In fact, at this point, you can just tell me the answer. What's the answer? The slope is undefined. Very good. The equation is just x equal pi. Because conceptually, visually if you like, what has occurred on this exercise is that I gave you 2 points. I gave you the point pi 13, and I gave you another point that was 1 unit above it at pi 14, and well, the line that goes through those 2 points is a vertical line. And the equation of that line is just x is pi. Any question about this example? Similarly, I'm not going to do it here, but if I gave you a part 3 and said, here's 2 points, and it came to pass that delta y was 0, then what kind of line would that be? That'd be a horizontal line. So if I gave you 2 points and both of the points had y coordinate equal to 8, then what would the equation of the line be? Y equal 8. Okay, any question about this?
Would you ask us the slope in this particular, like, with a situation like that, and then you would respond, it's undefined, slope is undefined? Or?
Right. So if I said something like, if I went on to say, find the equation of the line through the points, clearly state the slope. If I made that addendum there, then you'd say, here you'd say the slope is negative 1/3. And here you'd say the slope is undefined.
It's not, the slope is 0.
For this one?
Uh-huh.
No, the slope is undefined.
Okay.
Slope 0 is horizontal. Let's just do it.
Yeah. Okay, you're right. I'm sorry.
So as a third one, how about, I don't know, negative 5.8, comma 2. And how about 37? Why not? And 2. So 2 points there. Again, start out in exactly the same kind of way. Delta x is the difference in the x's. Oh, look at what I did to myself. So that'd be, what, 42.8? 37 minus negative 5.8. 42.8. Delta y, well, that'd be 2 minus 2, which is 0. The fact that delta y is 0 means that this is a horizontal line. If you so desired, you could say that the slope was, well, 0 over 42.8, which is 0. And the equation of the line is what? Y equal to 2. Any question about this one? Okay, so we have a formula for the equation of a line given a point and a slope, but some points we like to single out as being important, and one of those kinds of things that we single out are Y-intercepts. So this remark is about, well, what if the point that you have is a Y-intercept? So suppose that you are given the following. So let a line have slope m and Y-intercept zero b. Remember, because a Y-intercept is a point, you have to give it as something of the form x comma y. So let a line have slope m and Y-intercept 0b. Visually, we're talking about something like this. So this line has slope m, and then the point that we say that this line has is where in this picture? Right there. So that's the point 0b. That's the y-intercept. Then we could take this and plug in to the point slope formula. Y minus y1 equal to m multiplied by x minus x1. Well, that'd be what? Y minus b is equal to m multiplied by, what do I need to put in here? X minus 0. Okay, well, x minus 0 is the same as x. So this would be y minus b is m multiplied by x. And so then we can move the b over and get y as m times x plus b. Okay, so this last one is another formula that you're expected to memorize. It is the equation of a line with slope m and y-intercept 0b. Okay. So the name for this formula, if for those of you that like names, in my opinion is a bad name. It's called the Slope-Intercept Formula. So that's pretty good. But the problem with that name is that there's slight ambiguity, because how many kinds of intercepts are there? Two kinds, right? So you've got to remember that the name slope-intercept really means slope y-intercept, and not slope x-intercept. That's what it really means. Fine. As a result, I could say, for example, I could say find the slope. How about y equals 13x plus 14. So what's the slope of this line? 13, right? Because you're just trying to visually match, right? Y is mx plus b, y is 13x plus 14, m is 13. 2. How about 2y is 8x plus 12. What's the slope now? I thought it was 8. All right, you got to get the y by itself. So if we divide all positions by 2, that'd be y is 4x plus 6. So m is 4. 3. How about, I don't know, 3y is equal to negative 5x plus 4. Negative 5/3. So there's really no difference between this example and the previous example, except that now there's fractions, and that causes mild distress in some of you. So if you divide by 3, that'd be negative 5/3 x plus 4/3 So that gives you m is -5/3. And for the last example, how about, I don't know, 13x plus 14y equal 2018. What's the slope of this one? Okay, good. So how do you go about finding it?
Isolate y, observe y.
Yeah, get y by itself. Okay, so 14y equals -13x plus 2018. Okay, divide both sides by 14, and I'll show all a little bit more steps than usual because looking at the crowd, I'm seeing a little bit of question marks. So you divide both sides of the equation by 14. It's multiplied by 14 on the left-hand side and divide by 14 when you move it to the right-hand side. So then now this division distributes, because remember that division by 14, really that means multiplication by what? 1 over 14. So this distributes across plus. And you get, since I said it out loud, I might as well write it. This is the same as 1 over 14 multiplied by -13x plus 2018. So that'd be y is -13 over 14 x plus 2018 over 14. So the slope is negative for 13 over 14. Any question about this one? Okay. So now two related concepts, parallel and perpendicular. Two lines are parallel when so there's two different possibilities. The first possibility is the one that most students think of, and they're not surprised by it. So here's an axis, here's a line. Visually speaking, what would it mean for me to draw a second line that is parallel to the red one? Okay, so they're going to run sort of side by side and never touch, right? Or I draw the green one right on top of the red one because a line is parallel with itself. Well, suppose that the equation of the red line is y is m1x plus b1, and the equation of the green line is y is m2 x plus b2. Then yes, some of y'all already said it out loud. What's the slope of the red line? M1. And what's the slope of the green line? M2. What must be true about these slopes? Yes, these must have the same slope. That's one possibility. There's actually another possibility. And this, many students won't think of it, and then when I say it out loud, you'll say, yes, that's obvious, and okay, I guess this is a math class, so we have to say it. So what's the last class? The last possibility?
There's only one line.
For example, I could take the green one and put it on the red one, and that would be the case you were speaking of. That one. If they're both vertical. Now that's different than the previous case, because in the previous case you can say that they have the same slope. But you can't say that about this case because neither one of them has slope. Okay, so this could be something like x is equal a1 is the red line, and the green line is x is equal a2. So they either have the same slope or they're both vertical. Any question about the definition of parallel lines? Okay. 2. The counterpart to parallel is perpendicular. Again, there are two possibilities. So visually, qualitatively speaking, I've drawn a red line. What would it mean for me to draw a green line that is perpendicular to the red line? What does that mean? Okay, so visually, it's got to intersect, and moreover, it's going to intersect at a right angle. So it is, in a sense, kind of like the opposite of parallel. So for parallel, we were, that means the lines are either right on top of each other, or if they're not right on top of each other, then they're running side by side, and they're never going to touch. And algebraically, that means that the slopes must be the same. For parallel, what is the algebraic condition for perpendicular lines? What must be true? Okay, good. So the slopes are negative reciprocals of each other. So that means that if you take the two slopes and you multiply them together, you should get -1. The product of the two slopes is -1. But for the purposes of computation, it's usually a little easier to solve for M2 and say that M2 is -1 over M1. All right. So that's one possibility for perpendicular. What's the other possibility? Right. Just like this one was a, oh yeah, I guess that's a possibility. Here's the other one. It could be the case that one of the lines is vertical, like x is A, and the other line is horizontal. So, if I asked you about the slope of this red line, then how do you respond? It's undefined. And what is the slope of the green line? 0. Slope 0, undefined slope. Any question about the definitions of parallel and perpendicular? Okay. So now let's make sure that given a slope we can find the perpendicular slope. So for example, find the perpendicular slope. So what's the perpendicular slope to the slope m equal to 2? Negative 1 over 2. Because remember, to find the perpendicular slope you do two separate actions. You negate and reciprocate. Both. All right. What is the perpendicular slope to m1 is 3/2. Negative 2/3, right? Because reciprocal, well, the reciprocal of an integer, like 5, well, you could reckon 5 to be 5 over 1. And then reciprocal means, in a sense, switch the numerator and denominator. So you switch the numerator and denominator to get 2/3, and you negate.
I'm sorry.
Yes?
It's obvious, but I can't wrap my brain around it. Tell me the definition of the one for negate.
Put a negative sign in front of it. What is the perpendicular slope to, let's let everyone, so let's not say it out loud, let's let everyone do it. The perpendicular slope to negative 5/7. So what will it be? 7 over 5, because we're going to negate. So the negation, the negatives will cancel. And then reciprocal also. So 7 over 5. Okay, and finally, find the perpendicular slope to the line. How about 3x minus 8y is equal to 11. So I gave you a line. I don't want the slope of that line. Rather, I want the slope that is perpendicular to the slope of that line. Something like that. Yeah, so you got to start out by getting y by itself. And then I'll simplify just a little bit. So now I've solved for y. What's the slope of this line? 3 over 8. So what's the perpendicular slope? Negative 8 over 3. Any questions? Yes?
So for an equation of a line that's in the format of number 4, like 3 times x minus 8 times y, is it always going to be the case that the slope is the negative of the x coefficient over the y coefficient?
If it's exactly in this form, yeah. Yeah.
But like, even if it's flipped, it's still the negative of the x coefficient over the y.
As long as x and y are on the same side. Right? Because if they're on opposite sides, then something different. But similar is true. Okay, good. Other questions? All right, so here's sort of a typical question. Let point P be equal to, say, 2, 5, and let point Q be equal to, say, 6, and I don't know, 4, 5, 10. So we've got 2 points, P and Q. I want you to find the equation of the line through the midpoint of P and Q with slope perpendicular to the line segment. From P to Q. So concerning the quiz, unfortunately today, again, it is sitting on top of the printer, which is not a useful place for it to be. So, okay, I guess we're not doing it today. Fine. So I also, concerning this exercise, I want you to draw a sketch. So draw a sketch. All right, sketch. So suppose that this is point P here. Then where is Q relative to P? We're not trying to like plot it out with a ruler or anything. But where is Q with regard to P? So, right. So it's going to be a little bit to the right. What's telling you that it's going to be a little bit to the right? Well, 6, right? 6 is bigger than 2, so Q is going to be a little bit to the right. And similarly, 10 is bigger than 5, so it's going to be a little bit up. Okay. So we've got 2 points that are like so-ish. We want the equation of the line through the midpoint of P and Q. All right. So in this picture, in this sketch that we're making, where's the midpoint? Halfway between them, right? So then here's the line segment. There's the line segment between them. Here's the midpoint. Right there. So the line that we're looking for needs to go through that point. But there's a lot of ways to go through that point, right? So for example, there's a line going through that point, like that. Is that the one that we want? Maybe it's that one. That's the one we want, right? No? Okay. What needs to be true about the one we're looking for? Yeah, it has to be perpendicular to this segment, right? So the line that we're looking for is this red line, like so, and it needs to be perpendicular to the line segment. So what you were given is P and Q. Those are the 2 items that you were given. You need to find, well, anytime you're looking for a line, there's always 2 items that you're looking for. What 2 items? Point and a slope, right? Point and a slope. We weren't given either, at least not directly, which means that we must find both. So, well, because the formula is called the point-slope formula, and for no other really good reason, I'll find the point first. Okay, so let's find the point. How will we do that? Midpoint formula. Very good. Okay, so then x1, y1, yes. The x coordinate will be the average of the x's. So add the x's up, divide by 2. 2 plus 6 over 2. And then the y coordinate will be the average of the y's. Add the y's up, divide by 2. And so that would be 8 over 2 is 4. And then 15 over 2, I'll just leave as 15 over 2. Some of the time, in some of the exercises, I would have written 7.5 because, well, it's slightly less writing to write 7.5 than it is to write 15 over 2. However, on this exercise, it's going to be easier for us to use 15 over 2 because we're going to be adding fractions. So 15 over 2. Fine. Now what do we need to do? We need to find slope. But you need to be a little bit careful because what we're going to do is we're going to find the slope of something. The slope of what? The line segment, right? And you got to be real careful because that's not really actually the slope that we want. What is it that we want? Right, the negative reciprocal of that work. So I'm just saying that you need to carefully think about your work because I see students, because I've asked a question like this before, I see students make a drawing that looks great, midpoint looks great, they calculate the slope of the line segment, and then, you know, brain cramp, I don't know what, and then they just completely forget to even consider calculating the perpendicular slope. Okay, so the slope of the line segment well, delta x, that'd be 6 minus 2, which is 4. Delta y, that'd be 10 minus 5, which is 5. So the line that we're looking for, well, I mean the line segment anyhow. Is the line segment horizontal? Is the line segment vertical? No, right? That's asking if the line segment, we could detect that it was horizontal if that was 0. No. If the line segment were vertical, this would be 0. And if it was horizontal, that one would be 0. Okay, so the slope of the line segment is m1 equal to 5 over 4, which is not the slope that we're looking for. So what the slope that we're looking for is the perpendicular slope, which would be what? Negative 4 over 5. Okay, so does everyone see? We made a sketch. We determined that we're going to need a point and a slope. We found the point. We found the slope. Now it's just a matter of plugging stuff in. So y minus y1 is m2 multiplied by x minus x1. Okay, so y minus 15 over 2 is negative 4 over 5 times x minus 4. Okay, and the instructions are going to say, on exercises, it's going to say solve for y. Put it in slope-intercept form. Okay, so let's do that. Multiplying the negative 4/5 through on the right-hand side, what do you get? Very good. And then now add 15 halves to both sides. So negative 4/5 x plus 16 over 5 plus 15 over 2. Now, here's a neat thing, is that until basically this week, I've kept us in a walled garden, safe from all of the fractions, which are a source of anxiety. But that you know, that just can't go on forever. So on Wednesday, we're going to talk about fractions and get all that stuff squared away as best as we can. And then from then on, there's going to be fractions in all the exercises. But for now, I'm going to go ahead and do this, because let's make sure everyone has seen it and let that stew in your head until Wednesday. So, all right. To add, these can't be added together directly right now, because the denominator is kind of like what kind of thing it is. So the fact that the denominators are different, that is like saying that this is 16 apples plus 15 bananas. So you can't just add them up. So to get them to be the same, we need the denominators to be the same. Now, if we took this denominator and multiplied by 2, then it would be 10, right? So, but you can't just put a 2 in a denominator. That would change things. So what I'm going to do is I'm going to multiply by 2 over 2 to get 32 over 10 for the first one. So the first one, 16 over 5, is the same as 32 over 10. And what will I do with the second one? By 5. 5 over 5, right? So that would be 75 over 10. And now, oh, they're both, now this is 32 avocados and 75 avocados. So you can just add them up. And the answer is negative 4/5 x plus 97 avocados. Okay, have a nice Monday. That's not right. Sorry. 107, right? Okay, I'll fix it. But still have a nice Monday.
Scans are still not posted, right?
They're still not.
Okay.
I'll get it, I promise.
No, I was asking.